Hello and welcome to this module on sanitation products. In this section, we're going to talk about the different types of products, so the different liquids and solids that go into and out of a sanitation system. We have three goals in this module. The first is to understand why it is important to consider a range of sanitation products when you're planning a system. Secondly is to learn about what those different products are. And third is to be able to describe the characteristics of each of those products so we know how to best treat and potentially use them later on. Typically, when we think about sanitation, we think about two things, pee and poo. So the liquid and the solid excreta that come out of our bodies. But in reality, there are a lot more elements to consider. Certainly, urine and feces are two of the most important aspects to consider, but there are also many other materials that make the sanitation system work. Flesh water, for example. You can't have a sewer system without water to transport the urine and feces, and in many dry cities around the world, there is simply no flesh water, and therefore you would need to consider a different form of transport. There are other products that are generated throughout the sanitation system. Sludge, for example, is the thick, mucky layer that forms at the bottom of a septic tank. Sludge, because of its high solids content and viscosity, may be difficult to pump, but is also easily dried and therefore can be used as a soil amender. We'll come back to these examples later on. Here is a fairly comprehensive list of the products that should be considered when planning a sanitation system. There are others, of course, that are not listed here, but we'll focus on these ones for the remainder of this module and throughout this course. Let's start with primary products. Primary products, or the input products, are those that enter the sanitation system at the very beginning, so they enter through the toilet. Products, of course, do not stay separate, so they get combined and diluted. They take on different names as this happens. First, we have urine and feces. The name for these two things together is excreta. If you just add flush water to the feces, this is referred to as brown water. Brown water only exists when urine is separated at the source, and we'll talk more about this later in the module on technology. When anal cleansing water, so that's the water that's used for washing instead of toilet paper, or dry cleaning material, are mixed in with the excreta and flesh water, the whole mixture is referred to as black water. You may have heard the term wastewater before, but black water is a more descriptive term, and because any sort of unneeded water could be called wastewater, we prefer the term black water to be more specific. Gray water is the other water that's discharged from the house and may include all the other types of water that are generated in the kitchen or from laundry or from hand washing. Here in this photo from Maputo, Mozambique, we can see two men collecting water in small storage containers. If you can imagine the water that it would take to flush a toilet constantly in order to transport all of the household wastes in a toilet, you can imagine how much work would be needed to collect the quantity of water required. It's one of these examples where we would have to think of a different transport system for the products that would be entering into the sanitation system. Here we can see the different characteristics of gray water, urine, and feces. Looking first at volume, we see that the quantity of gray water generated per person is immense, whereas the volume of feces, only 50 liters per person per year, is relatively tiny. We can see also that the majority of the nutrients, nitrogen, phosphorus, and potassium, are in urine, with a smaller amount in the feces and very little in the gray water. In the last row, we can see the quantities of fecal coliforms that are present, and clearly they are concentrated in the feces. Gray water has what may be a surprising amount, and these come mostly from hand washing and showering. Urine, you'll notice, has none. The small star indicates that urine is pathogen-free in the bladder of healthy people, so pathogens in urine that is collected outside of the body may still be pathogenic. In summary, then, we have large quantities of gray water with relatively no nutrient value, urine, which is generally clean and nutrient-rich, and a very small amount of feces that are highly pathogenic. Knowing all of these characteristics can help us decide on the best ways to store, transport, and use the products in our sanitation system. Secondary products are those products that are generated within the sanitation system because of some type of transformation. If you store urine for long enough, so about a month or so, the pH and ammonia concentration will increase to the point that it becomes self-sterilizing. So that means that most of the pathogens in the urine will be destroyed, and that urine can safely be used as a nutrient source. All that's needed for this type of transformation is time. Similarly, feces can be dried simply in the presence of time and heat, and once fully desiccated, the feces will be, depending on the temperature and storage time, quite hygienic. These processes are, however, only applicable to the products if they are separate. If excreta is left in a pit, remember the mixture of urine and feces, and is allowed to degrade naturally and slowly over time, the resulting product will be an organic material, not unlike compost or humus. Black water, on the other hand, is a mixture of all the things we discussed before: feces, flesh water, toilet paper. And after time, or with some kind of physical process, the solids will separate so that you'll be left with two new products: a semi-clarified effluent and a dense sludge of the solids. Here we can see a bit of what the sludge looks like. It's a thin sludge, but it's still a typical sludge. These are trucks that have collected the sludge from septic tanks or pit latrines and are discharging it onto an empty field, which unfortunately is not uncommon. Fecal sludge must be removed constantly from many household-level technologies, and yet there are few treatment processes available that are able to treat it. Here is a great example of a sludge drying bed. The sludge trucks from the previous slide would come here, dump their sludge onto one of these dedicated drying beds. The beds are made from layers of gravel and sand. The sludge layer is applied on top, and the solids stay on the sand layer and dry out under the sun while the effluent percolates through the sand and down through the gravel where it's collected. The effluent, don't forget, is another new product that must be treated in a separate process before it can be discharged into the environment. In the same way that sludge settles to the bottom of black water, lighter particles will rise to the top. Fogs, fats, oils, grease, and surfactants, FOGS, is the name given to all the frothy scum that floats to the top of a wastewater, particularly gray water. Fogs generally comes from the cooking fat and soaps that are used in the kitchen. Fogs can clog pipes and pumps if it's not removed early in the sanitation chain. Here you can see a nice example of a simple interceptor tank that prevents the fogs from entering into the small pipes. After some time, that little strainer on the left would be used to remove the fogs and keep the small interceptor functioning well. Most of the products that we've discussed so far are materials that are pathogenic or harmful to the environment in some way, but the products we're going to talk about here are ones that can be produced by a sanitation system and are actually beneficial. Compost, or humus, can be created with the dried fecal sludge we saw in the earlier slide, simply by processing it with some sort of organic material, like market waste. And biogas, which is the result of anaerobic digestion and consists mostly of methane, can be collected and used as a fuel for cooking and lighting. These types of beneficial products are not difficult to produce, but they must be considered in the early stages of sanitation planning so that the most value from the system can be obtained without waste. Here we see a diagram and an example of a fixed dome biogas reactor. So just wrapping up what we've discussed so far, there are a lot of products besides pee and poo that need to be considered. Each product will contain a different quantity and variety of nutrients and pathogens, which will influence the treatment requirements and also the potential use options. The volume of each product will greatly influence how it's transported and treated within the sanitation system. The range and type of products in a sanitation system will determine the number, type, and sequence of technologies that will be needed in the final design.